Good morning, dear students.
Good morning, sir.
Good morning, sir.
Good
Good
morning,
morning,
sir.
sir.
Welcome to the class of
Good morning,
chemistry.
sir.
I hope you can see the screen. On your screen, what is written?
Surface tension, sir.
Great. So, in the last period, we have studied about the surface tension. We have seen that when a liquid has got bulk and surface, on surface the molecules have on the surface, my dear students, the molecules have imbalanced forces. So they have the net attraction into the liquid. At the same time, we have seen that the molecule present in the bulk have net forces. Due to this, the molecule present on the surface does not want to be on the surface because it feels some energy. So it has got more energy. This energy which is possessed is known as the surface energy. Actually, surface energy is the energy that is expend or by the expenditure of that energy, the surface keeps the molecules on the surface because no molecule want to remain on the surface. So molecule wants to stay on the surface by expenditure of some energy. That energy is known as the surface energy. And my dear students, no molecule as they want to stay on the surface, they always want to go towards the bulk. So some extra force that has to be applied in the opposite side, that extra force that we apply is perpendicular to the surface, and that force we call it as a surface tension. Due to surface tension, we see lots of phenomena like some insects can walk on the surface because there is a thin film of the molecules present on the surface which feel some strain, which feel some tension, and that is how the surface is little tense, little stretched, and on that the various insects can walk. You can see the meniscus of the liquid into the various tubes. So the meniscus can be the in concave or convex. This concave or convex meniscus is formed due to the surface tension. You can see that the various molecules or various particles of sand, they also get collected, and they are due to the collection they are used in such a way that they try to remain in clusters, but when there is no water they do not remain in cluster. That is because of the surface tension. The water wants to make the thinnest possible layer among the particles of sand. Same way, my dear students, when we want to make the surface of glass smoother, we just heat it. As the glass is being heated, it turns into the liquid state. We know that the droplets or this spherical shape has got the minimum surface area, and thus they have the minimum surface tension. And as the surface area and surface tension are minimum, the glass turns to be smoother at the corners, and this is what it is known as the polishing of the glass. Same way, my dear students, we have seen that whenever the liquids falls, they form the droplets. These droplets are majorly spherical in shape, and this spherical shape of these various droplets is because of the because they want to keep their surface minimum, and as they want to keep their surface minimum, my dear students, they make the surface spherical shape. At the same time, due to the effect of gravity, these spherical droplets are sometimes or majorly flattened at the bottom. So this is how, my dear students, we understand about the various uh, effects as well as the various properties of the surface tension. Now today, my dear students, we want to start studying about the liquid state. So We have already started studying about the liquid state, I'm sorry, but today we want to start about studying about the next property of liquid, that is what we call it viscosity. So let's start. We have done the revision as far as possible. Now we can move to the next property of a liquid, that is what it is known as the viscosity. Let us first look at the definition of the viscosity. Viscosity is the measure of resistance to flow of liquid which arises due to the internal friction between the layers of fluid, that is liquid, as they slip past one another while liquid flows. My dear students, please try to understand this definition. To understand this definition, you must know that liquid flows on the layers. So their molecule makes some layers, and these layers slip past one another, and this is how the liquid flows. So when the layers are slipping past one another, they feel some friction. This friction opposes the flow of the liquid, and this is what it represents, the viscosity. Now I hope you will understand the definition once better. Let me read it once again for you. Viscosity is the measure of resistance to flow of liquid which arises due to the internal which arises due to the internal which arises due to the internal friction between the layers of fluid, that is liquid, as they slip past one another while the liquid flows. So it's simply a characteristic that opposes the flow of liquid. Strong intermolecular forces between molecules hold them together and resist the movement of layers past one another. See, liquid molecules have strong intermolecular forces as compared to gases, and that is why these strong intermolecular forces between the molecule hold them together and resist the movement of layers past one another. So please pay attention and understand this figure that I am going to explain to you. All of you please pay attention and try to understand the figure that I am going to explain you. You can see, my dear students, here in this figure that we have a tube. In this tube the liquid is flowing. So when the liquid flows in a particular tube, my dear students, we can see that these two layers, this layer I'm talking about and this layer, they are in touch with the tube, and that is why they have zero velocity, or they are stationary or fixed surface. Please try to understand, the first layer from both the sides is stationary layer, or it is the fixed surface. They do not move, they remain stick. This layer remains stick to the tube itself through which this liquid is flowing. Now my dear students, as we go away from the fixed layer, suppose we move to the layer 1 dash, or we move to the layer 1. So while going from this layer to this layer, you can see that the change in the velocity is dx. So when you even go up or when you down from the stationary surface, the velocity changes. Now, how does the velocity changes, my dear students? That if you go down or if you go up or if you go towards the middle, the velocity of the layers increases because they are going away from the stationary or fixed surface, and that is how their velocity increases. So you can see that the first dash layer has the velocity of dx, then the second layer has again an increase into the velocity. So dx plus ds, that becomes 2 dx. Then the third layer has got 3 dx, and third dash layer also has got 3 dx. Four layer and fourth dash layer also have got 4 dx. So as we go, and the center layer has got the highest velocity of 5 dx, my dear students. So this is how you can easily understand that this layer, this fifth layer, has got the highest velocity, which is the 5 dx. So this is how the liquid makes layers, and they flow with one another. That is what I have explained. Now see, this is the portion which I have taken for our study, and that we will discuss in later discussion. So we will be studying, layer 2, layer 3 and layer 4. Layer 2, layer 3 and layer 4. We will study in detail to understand the viscosity better. Let's move forward and read the text. Flow of liquid through the pipe. Now this flow is known as the laminar flow. So let us understand what is laminar flow. When a liquid flows over a fixed surface, the layer of molecule in the immediate contact of surface is stationary. Please remember that the layer which is in the immediate contact of the surface is, uh, is generally the stationary layer or is fixed layer. The velocity of upper layers increases as the distance of layers from the fixed layer increases. So if the distance from the layer and a fixed layer increases, you can see here as the distance between this fixed layer increases, the velocity increases. So as the distance from this layer increases, velocity increases. Here also you can see that the velocity increases as you go down the group up to 5 dx. Let's once again look at the understanding of the laminar flow, my dear students. That when a liquid flows over a fixed surface, the layer of molecule in the immediate contact with the surface is stationary. The velocity of upper layer increases as the distance of layer from the fixed layer increases. This type of, remember my dear students, this type of flow is known as the laminar flow. So this type of flow, how in which there is a regular gradation. Please understand that this type of flow in which there is a regular gradation. This is the flow. This type of flow in which there is a regular gradation of velocity in passing from one layer to the another is known as the laminar flow. So the flow that we have seen in the tube, my dear students, where each layer, when we go towards the center of the tube, the velocity increases, and that is how we get the gradation of velocity. Gradation of velocity means the difference in the velocity for the various layers. This or such type of flow is known as the laminar flow. In the figure, we have seen that the velocity 5 dx is more than 4 dx is more than 3 dx is more than 2 dx is more than 1 dx. This is what it represents, the gradation of velocity. This is how, my dear students, we understand. So, stationary or fixed layer has zero velocity. Please remember that this layer which was fixed, it has got the zero velocity. We have represented it as the zero velocity. Let us study layer 2, layer 3 and layer 4 separately. Now, my dear students, we just want to study these layers which are layer 2, layer 3 and layer 4. So you can see we have layer 2 here, layer 3 here, layer 4 here. Layer 2 has got the velocity 2 dx, layer 3 has got the velocity 3 dx, and layer 4, the velocity we call it 4 dx. Suppose 3 dx is equal to u and dx is equal to du. Suppose 3 dx is equal to u, 3 dx is equal to u, and dx is equal to du. Now in this case, what do you understand? Dx is equal to du. So my dear students, when 3 dx is u, we have written u. Now suppose you write u minus dx. That is, you write 3 dx minus dx, which give you 2 dx, but dx is equal to du. So we can write for 2 dx, we can write u minus du. So I have written u minus du for 2 dx and u plus du for 4 dx. So this is how, my dear students, we understand this figure, that we have layer number 2, 3 and 4. In layer number 3, we have the velocity u. If you go up, the velocity increases by du. If you go down, the velocity decreases by du. So when you go down, my dear students, the velocity decreases. When you go up, the velocity increases. So while going down, the velocity decreases. When going up, the velocity increases. We are just studying these three layers. That is how we can understand the gradation of velocity in the laminar flow. The distance between the two layers is considered as a dz, and the area of the plate which comes in contact with this unit area is represented as A. So my dear students, when these layers are flowing, now we want to understand the layers separately. So we have chosen the layer number 2, layer number 3, layer number 4. We call the velocity of layer number 3 as u. So the velocity of layer number 2 is u minus du, and velocity of layer number 4 is u plus du. Now what happens? The distance between the two layers has been considered as a dz, and the cross section area that comes in contact with the another layer is A. So in the above figure, we chose selected layers 2, 3, 4. For convenience, let's say the velocity of layer 3 is u. So the velocity of layer 4 is u plus du, and velocity of layer 2 is u minus du. The same I have tried to explain. U is equal to 3 dx, u minus du that is 2 dx, u plus du that is 4 dx, and du is equal to dx. A is known as the area of contact, and dz is the distance between the two layers. Let's move forward. Now du is the change in the velocity, my dear students. So let us let us understand that du is the change in the velocity going from one layer to another layer, and going from one layer to another layer at the distance of dz. This velocity gradient, that is the change in the velocity per dz distance, is written as du by dz. So the velocity, that is what it is known as the velocity gradient, that for velocity gradient, the change in the velocity per dz distance, again, the change in the velocity per dz distance is written as a velocity gradient, and here the velocity gradient for us is du by dz. But layers keep on flowing through, layers keep on flowing. You see, we know that liquid flows in the tube. So layers keep on flowing, though there is a friction between two layers. So there is a friction between the two layers, and that is why the layers keep on flowing. A force is required to maintain the flow of layers, and the force is proportional to area of contact of the layers. So some force is required, and this force is directly proportional to the area of contact, and that force is F proportional to A. So this force which is required is F, and that force is a force depends upon the area of contact. At the same time, this force also depend upon the velocity gradient. My dear students, once again I would like to explain this to you. We know that the liquid flows into the tube, or liquid flows. When liquid flows, my dear students, this flow has been opposed by some force. This force is directly proportional to the area of contact of layers, and this force is also depending upon the velocity gradient. So collectively for this equation 1 and 2, we can write that force is proportional to the area of contact, and force is proportional to the velocity gradient. When we remove this proportionality, we write a proportionality constant here, which is known as eta, and that is what? Eta is known as the proportionality constant and is called the coefficient of viscosity. So when we remove the proportionality, mathematically we write a constant eta. That eta is known as the coefficient of viscosity. When you put the value of A is equal to 1, and when you put the value of du by dz is equal to 1, so if the area of cross section is unit, and if the velocity gradient is 1, we know that this force is equal to coefficient of viscosity. And this is how, my dear students, we define this term. Let us look at the definition. Coefficient of viscosity is the force. We have just seen that it is force is equal to eta when you have one area of cross section or area is unit and your velocity gradient du by dz is also 1. So coefficient of viscosity is the force when velocity gradient is unity and the area of constant or the area is unit area. So that is how, my dear students, we understand the coefficient of viscosity. N is the measure of viscosity. So eta is the measure of viscosity. The coefficient of viscosity itself represents the viscosity. Now, my dear students, we are going to study about the units of coefficient of viscosity. So we know that F is equal to eta into A into du by dz, and therefore, my dear students, eta is equal to F divided by A into du by dz. We just move this term this side and this is how we write it. For force we write Newton, for area we write meter square, and for change in the velocity we write meter per second square. This is for velocity and this is the distance between the two layers, and ultimately we get the new unit for coefficient of viscosity, which is known as Newton into second per square meter. You can see that Newton into second per square meter. Let us understand the other units, my dear students. See, eta is equal to F by A into 1 upon du by dz, that is force divided by area, into 1 upon du by dz, that is force divided by area. It simply can be written as a pressure. So it is pressure into 1 upon du by dz. Pressure is measured in Pascal. Du is meter per second square, meter per second, sorry, not square, and your distance between two layers is in meter, and thus we finally get the Pascal into second. This is again one of the unit for the eta, that is the coefficient of viscosity. Same way, we have seen that the one of the unit of our eta is Newton into second per meter square. Newton is force, that is second and per meter square. You know, force is mass into acceleration into second per meter square. For mass we write kg, for acceleration we write meter per second square. We already have second and meter to the power minus 2, that is 1 upon meter to the power 2, and this is how we get the another unit, that is kg per meter per second for the uh, coefficient of viscosity. Now, you know, we want to convert this kilogram into gram, so we'll write for 1 kilogram we'll write 1000 gram. It is meter per meter, so we have written 1 upon meter into second. So now 1 kilogram is 1000 gram, 1 meter is 100 centimeter per second, and that is how we can say that 1 kg per meter per second is equal to 10 gram per meter, 10 gram per centimeter per second. By cancelling those or by dividing 1000 with 100, we get 10, and this is how we can get this relationship developed, that 1 kilogram per meter per second is equal to 10 gram per centimeter per second, or we can say, my dear students, that 1 gram per centimeter per second is equal to 10 to the power minus 1 kilogram per meter per second. So this is how these are even the units of the coefficient of viscosity, and this is how, my dear students, we understand the various units of coefficient of viscosity. We have seen these various units. Let us revise them. One is Newton per meter per Newton into second per square meter. We have seen Pascal into second. We have seen the new unit what I am going to introduce you is now known as a poise. The CGS system unit of coefficient of viscosity is poise, named after great scientist Jean-Louis Poiseuille. One poise is equal to 1 gram per centimeter per second, and that is, this is the relation that we have seen, that 1 poise is equal to 10 to the power minus 1 kilogram per meter per second. Now, my dear students, we want to study about the factors affecting the viscosity. So let's pay attention to the factors affecting the viscosity. greater the viscosity, the more slowly the liquid flows. So, we have honey, we have castor oil. They are more viscous than the water. So, this is how we can say that more is the viscosity, slow they flow. Hydrogen bonding and van der Waals forces are strong enough to cause the high viscosity. So those liquids, they have hydrogen bonding or strong van der Waals forces. They cause high viscosity. Temperature also affects the viscosity. Viscosity of liquid decreases as the temperature increases. So my dear students, please remember that viscosity decreases as the temperature increases. And why does it happen? Because at high temperatures molecules have a high kinetic energy, and that is why can overcome the intermolecular forces, and that is why they slip past one another between the layer faster, and that is why as the temperature increases, my dear students, the viscosity of the liquid decreases. Viscosity of liquid decreases because the the moments or the kinetic energy increases, and that is why the particles start moving faster. And as the particles start moving faster, my dear students, this particle uh, decreases, or thus the intermolecular forces of attraction can be overcome easily, and that is why the viscosity decreases. Now a very important point about this is give reason why gases are called supercooled liquids, or gases are called extremely viscous liquids, or gases of window panes of old buildings are thicker at bottom than the top. So these are the various regions, or these are the various points that can be answered by some very simple explanation. Let us have a look to that explanation, my dear students. Let us study the answer for all these questions. Now remember, whatever I say, glasses can flow. So glass can flow, and that is why we call them liquid, or we can call them liquid. So glasses can flow, but their rate of flow is very slow. So they flow very slowly. Over so many years, the glasses of window panes of buildings flow towards the bottom. So these glasses of window panes, they flow towards the bottom, and they flow towards the bottom under the gravitation force, so that if we measure the thickness of the window panes of old buildings, these become thicker at the bottom. So if we measure the thickness of the old panes of the window building, and we will find that the bottom of these glasses are more thicker than the top of those glasses which are present into the window panes of old building. So the window panes of old building become thicker at the bottom as compared to the top. Thus glasses are supercooled liquids or extremely viscous liquids. So my dear students, please remember that this glass can be flow, and that is why it is liquid. Over a long period of time, they flow under gravity towards the bottom, and that is why the bottom of the glasses of the various window panes in the old buildings are thicker at the bottom as compared to the other as compared to the top. So my dear students, let us do a simple and a quick revision of whatever we have studied today. Today we have started studying about the viscosity. Viscosity is the measure of the uh, force of friction, or viscosity is the resistance that has been provided to the liquid when the liquid is flowing. We know that liquid flows into the layers. So when you go away from the fixed surface of the tube or some vessel in which the liquid is flowing, the velocity of liquid layers increases. So as you go away from the fixed surface, the velocity of liquid layers increases. This is what it is known as the velocity gradient, and such flow of liquid is known as the laminar flow. In the laminar flow, my dear students, if the if A is the area of contact between the layers, dz is the distance between the two layers, and the velocity of one layer is u, whereas the upper layer is u plus du, and lower layer is u minus du. The velocity gradient we can write is du by dz, and this is how, my dear students, the force that oppose the flow of liquid is, if we write it F, that flow depends upon the area, that flow depends upon the um, velocity gradient, and ultimately we can say that the force depends upon two factors, area as well as the velocity gradient. Thus the force is equal to the proportionality constant into area into du by dz. This proportionality constant is known as the coefficient of viscosity, and when the value of the area of contact and the velocity gradient is 1, we can easily study the we can say that the force applied or the force exists is actually the coefficient of viscosity. So this is how we can define that coefficient of viscosity is the force that is opposing the flow of the liquid when area is a unit, and the velocity gradient